Hello everyone. Let us look into this question right now. Evaluate integration of x square dx by x to the power of 4 plus x square minus 2. So now let we assume that x square equal to t. Now x square by x to the power of 4 plus x square minus 2. This I can write it as, in the place of x square, when I substitute t, I will get as t by t square plus t minus 2. So this I can write as t by t square plus this t I can write as 2t minus t minus 2. So this will be t by t into t plus 2 minus 1 into t plus 2. So this I will get it as t by t plus 2 into t minus 1. Okay. Now t by t plus 2 into t minus 1. When I split in the form of partial fractions, I can write it as a by t plus 2 plus b by t minus 1. Right. Then I'll get it as t is equal to, when I take the LCM and simplify this, I'll get as t equal to a into t minus 1 plus b into t plus 2. This, on further simplification, I'll get as t into a plus b plus 2b minus a. Now from when you equate the coefficients, equate the like terms and all those, I'll get as a plus b equal to 1 and 2b minus a equal to 0. Right. Now, on further simplification of this, so from here, I'll get 2b is equal to a, I'll substitute here. So in the place of this, from this part, 2b equal to a, I'll get it. I'll, in the place of this a, I'll substitute 2b. Then I'll get as 3b equal to 1. From here, b equal to 1 by 3. Similarly, when I substitute b equal to 1 by 3 here, since a is equal to 2b we have, then a I will get as 2 by 3. Right? So therefore, t by t plus 2 into t minus 1. This I can write it as 2 by 3 by t plus 2 plus 1 by 3 by t minus 1. Right? So this t by t plus 2 into t minus 1 is nothing but the main part. Okay, now when I resubstitute again in the place of t as x square, so finally what I will get? I will get this as x square by x to the power of 4 plus x square minus 2 equal to, right, this t was nothing but x square. So this simplification only, t plus 2 into t minus 2, I got the same thing. So I can write it as 2 by 3 by x square plus 2 plus 1 by 3 by x square minus 1. Now when you go to our original problem, that was nothing but integration of x square by x to the power of 4 plus x square minus 2 dx. So when I apply the integration for the terms, the simplified part, I will get here, I will get it as integration of 2 by 3 by x square plus 2 plus 1 by 3 by x square minus 1 dx. So this will be, when you separate this one, I'll get it as 2 by 3 integration of 1 by x square plus 2 dx plus 1 by 3 integration of 1 by x square minus 1 dx. Right. So on further simplification, I can write it as 2 by 3 integration of 1 by x square plus this, I can write it as root 2 whole square dx plus 1 by 3 integration of 1 by x square minus 1 square dx. Right. We know the formulas for this. Right. That is, since integration of 1 by x square plus a square. This is in this form, right? X square plus a square. Dx is equal to 1 by a tan inverse x by a plus c. And the next one, integration of 1 by, this is something in the form of 1 by x square minus a square dx. So that is 1 by 2a log of mod x minus a by x plus a plus c. Right. Now, these two are the formulas here. Now, I'll substitute the complete part, that is 1 by x square plus root 2 whole square. I'll write in this manner, and this 1 by x square minus 1 square, I'll write in this manner. So, finally, what I'll get here? Therefore, integration of x square by x to the power of 4 plus x square minus 2 dx is equal to, so 2 by 3 into this one, 1 by x square plus root 2 whole square, I can write it as 1 by root 2 tan inverse x by root 2, right? 1 by a tan inverse x by a. Similarly, this I can write it as 1 by 3 into 1 by x square minus a square. So 1 by 2a log x minus a by x plus a, right? So that means I can write it as 1 by 2 log mod x minus 1 by x plus 1 plus c. So therefore, finally, I'll get as x square by x to the power of 4 plus x square minus 2 dx. This I can get it as 2 by 3 root 2 tan inverse x by root 2, right, plus 1 by 6 log of mod x minus 1 by x plus 1 plus c, right? This is the final answer. I hope you got the solution here. We'll meet with the next question. Once again, thank you.